is that, first of all, it is determinate. There's nothing about indeterminate about it. Remember, this is a pin on one side, a roller on the other side. This is obviously from a static class. You know that. That's the determinate problem. So you can calculate for RA and RC in this case. Is that correct? Although a couple of people make a mistake there, but nevertheless, one is 180, the other one is 145. So you do not have to worry about the static of the problem. The static of the problem is already being solved in this problem. I'm just asking you to practice something which was essential, which some of you didn't do that. Notice the most important part of this problem is this. From A to B, there is no load, shear is constant, moment is linear, yes or no? From B to C, the moment is a parabola, correct or not? How can this be expressed as one function? So it is two different functions. Everybody understand that? And if we want to answer the entire question, we have to set it up for two parts. Notice some of your homework were two parts. I did one example or two on class, two-part scenario. Some of your homework did not require two parts, and I'm going to explain that one more time. I don't want you to make a mistake there. So one of the problem was like that you had here a load there and a load here, something like that. You remember that I'm talking about last homework. Is that correct or not? There, you only have to do AB because no question was asked about C. Because if you want to find the deflection under the C, then you have to do AB and BC. Since the question was at the beginning of the homework set, therefore, they did not ask you to do anything about C. So I asked you can bring this one here and treat it as one beam, which I'm supposed you did it. There was another problem that it was like this. And then load was like that, which was symmetrical, yes or no? If it is symmetrical, then you don't have to do it between two span from here to here because it's symmetrical, so you only set it up with half. Everybody understand it. However, I gave you another problem, which was the load here or somewhere like that. Remember that problem? And that problem, you have to do it left-hand side and the right-hand side. You must have done it, so this should not be a problem for you. Is that correct? But unfortunately, about 10, 15, 20% of the class did not do that. Is that correct? They only look at the second part, as if the first part doesn't exist, which ruined the whole system. Is that correct or not? Nevertheless, this is in two parts. One part is between A to B. I mean, if you miss that, you miss the whole boat, everybody. But still, I give you 8 point or 10 point, depend what you did, which is not really relevant. But I gave you some credit. Everybody understand. I thought maybe you missed something. But nevertheless, this has to be set up between A to B, totally different between B to C. Another reason, what was the reason for us to go through the singularity function? What was singularity function that you love it so much? Remember last week when we were talking about singularity function, which I asked you to do it as a homework. I hope all of you have done your singularity problem, have done your superposition problem, maybe a question on here or two. I saw many people during the office hours who have done that. Many of them didn't have any question about this singularity. Most of the questions were about the superposition method. Is that understood? Nevertheless, what I'm saying that in order to bypass that, I said it many, many times. I asked you many, many times. If I said I have a load here, 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 how many times do we have to break this into system? All of you said 1, 2, 3, 4, 5. Remember all that discussion? Here you have to break the system into 2. Is that correct? That is cardinal. I mean, you cannot do this problem without looking at it that way. And if you are doing only one part or the other part, is not going to get you anywhere. Is that correct or not? Yes. First of all, it's determinate. Second, if I'm interested of deflection here or theta here, I have to do it in two parts. Otherwise, it's not, even if I put AB, there are unknown that I cannot resolve it. Anyhow, EI d2y over dx squared become equal to moment at this section. What's the moment at that section? It could not be simpler than that. It's 180 times x. Yes or no? Correct? Plus or minus? Plus. How many people do you think put minus there? Because they have not got out of the static yet. This static, we are not talking about 180 times that. We are talking about the moment in the body of the beam who are going to be reacting to that. Is that correct or not? So this moment is negative. That moment, this is the m we are talking about. Yes or no? How many of you are drawing it there, but then you are not using your static properly? Is that correct or not? Anyhow, another 15% of the class or 20% put here minus. It is 180 times x. Is that correct or not? Action is negative. The reaction to that, the sum of these two must be equal to 0. This is RA. This is the mx that I'm looking for. Is that correct or not? That mx, if this is 10 and this is 2, 10 times 2 is 20 going that way. This m should be 20 going that way. Therefore, it should positive. This is the one, it goes there. Is that correct? This is internal moment which causes a stress. Is that correct or not? In the sine the beam, correct? Yeah. No problem there. But still, there are people who make a, how can you go through ME 218 and not recognizing this fact? That all the stresses you put sigma equal to MC over I or tau equal to TC over J, those are all internal, not the external. Understood? Yes or no? You put sigma equal to P over A, first lecture of ME 218. That is not P, that is N. Remember that? That N means normal force in the body of the, right, correct? Everybody understand what I'm saying that? I don't know. Still, you are quiet, guys. I have a rod here. I have P1. I have P2. I have P3. I don't care about this one. I want to find this N. Everybody, and that N gives me the stress at that point. Yes or no? I may have 50 P there. I don't care. I have only one N. And that N is the normal force. I may have this force, this force, this force, this force. Then I have here one shear. Is that correct? That. And also as the result of all of that, I have one M. Everybody, this is chapter 6. This is chapter, I'm sorry, this is chapter 5. Sigma equal to MC over I. This is tau equal to VQ over IT. Is that correct or not? And this is chapter 1. Is that correct or not? In that respect. So why you are making mistake, you are putting minus here. You are taking the moment of this RA about this point. Is that correct? That's a no-no. Nevertheless, everybody understood there. Yes? Now let's go to the other one. EI d2y over dx squared, which is totally different format. These are the format of this beam is going to bend like this. Then I said it in class. Actually, I showed you in two color. I said, remember, if you go like that, you may end up like that. Let's say it ends up like this. This is by exaggeration. Is that correct or not? Yes? This curve is this curve. Is that understood? Yes? This black curve is this curve. Is that correct or not? Yes? That y represent from A to B. The other y represent from B to C, which be this elastic curve. This is the y, expressed as a function of x, like any other parabola or whatever. Is that correct or not? Yes? You getting the idea? That's why you should not make this kind of mistake. Anyhow, I don't want to put here. Here I can put the color on top. So this is region, purple region. Let's put it this way. This is the purple region, and that's the black region. Is that correct or not? Nevertheless, I hope that you understand what I'm talking about after you go through the quiz. Of course, that's a little bit too late. So you get, again, I ask you to use the same system of coordinate. Now, some of you recognize that if I make a cut here, this was cut 1. For cut 1, this is the M, yes or no? Then I have to use for cut 2, which is now this or that. Is that correct or not? Some of you use this part, but you made a mistake here, or not a mistake. You use something that I did not recommend it to you, which is correct. Some of you change your x like that. I don't know. I have to look to see what. I'm saying this because some did like that, because they want to go this way as if it is simpler. They saw it actually in the Hibbeler book. They would recommend that, which I always change that one. I said never use that method because you get into lots of math. This is the only difference that you use to follow the system that I show you in class. The math become much, much simpler. Everybody understand that. You change that, you can do it. There is nothing wrong there. But remember, if you are at this point, let's say x here equal to 3. At this point, x equal to 2. Everybody understand what I'm saying that. So you can use this method. Few of you try to use. I ask you not to do, plus the fact that on the quiz I said use A as center of coordinate. Yes or no? If that's the center of coordinate, then this distance from here to here, let me draw the free body diagram. This was the free body diagram of part AB. Now the free body diagram of part BC is like that, guys. 125. This is the load. This is 180. You want to put that as for the last time. Everybody is correct there. You should not. Few people made the mistake. This is not B. Some people call this point B or C or E or D. I don't know. That's not the point. That is at distance of X. So this becomes shear at point X. And this is M at point, and it has to be this way. You cannot put it negative. If you put it in negative, everything will be in negative format. Yes or no? This is the positive direction we are assuming for our shear and moment diagram. Yes or no? Correct? So the question is, what is mx? Now, many people had problem there. I'm going to write it, and you see it is correct. Equal to 180 times x. That does not change. It's still 180 times x. This load is 125 times this distance, which is not x. It is x minus, how much is that? X minus 1. So the other one is P, x minus 1, yes or no? But whether it's plus or minus, again, we have to go with the sign convention. Notice the action is positive. The reaction to that should be negative. So that this goes plus, this goes minus, yes or no? But at the same time, at the same point, aside from them, we have a uniform load. You see, uniform load should be a parabola, wx squared over 2, yes? But x start from here, not there. Everybody understand that. Therefore, will be minus the same thing, w times x minus 1 to the power of 2 over 2. So that is your system that you used it in your singularity method. If any of you use a little bit of singularity, you will realize that's the case. Is that correct or not? Now, the second or the third cardinal rule, which is very, very important, especially for this problem, I ask you not to expand this. Remember that? If you expand that, you get the answer, but you get different answer. You get different answer for C1, you get different answer for C2, but you solve the problem, but with twice as much math. If you keep this one in this system, which is similar to singularity, that's what I'm saying, that your math reduces. So let's keep it in this format and go forward. So this is the moment for section 1, correct or not? That's the moment for section 2. As you see, this is totally different from that one. So this curve and this black curve have nothing in common to each other except when they join each other. Is that correct or not? Which we get to it in a minute. So let's process that. EI theta, let's call it theta 1 or black area, equal to 180x squared over 2 plus C1. Then EI y1 equal to 180x3 over 6 plus C1x plus C2. That's the integration of that part. Correct or not? Which many people did correctly. This one become theta 2, 180x to the power of 2 minus p x minus 1 to the power of 2 minus w x minus 1 to the power of 3 over 6. Notice the w was given to you, p was given to you. You can put the number there. Everybody understand that. Many of you did, which is perfectly okay. Is that correct or not? But please do not expand it. Some of you did. You could never finish the math in 15 minutes, 21, because you did not follow that rule that I asked you to do it. Then next one is EI. You see in a minute what's going to happen. Y2 equal to 180x3 over 6 minus p x minus 1 to the power of 3 over 6 minus w x minus 1 to the power of 4 over 24. Oh, this one has plus 3, C3, and this one has C3x. You cannot see it from that corner. I'll put it here, plus C3x plus C4. I have 4 boundary condition I have to resolve. Is that correct? For constant of integration, C1, C2, C3, and C4 with system I show you. Now, at X, look at this. This is the boundary condition, but does not apply to the purple one. Apply to the, some of you put it all over the place. Look at your note, what you have written. Put X equal to 0, Y equal to 0. You apply it here, and again apply it here. Did that make sense? Yes? Correct or not? Y equal to 0 belongs to beginning of black line. Is that correct? X equals, this even doesn't have X equal to 0. X starts from 1 to 5. You have a curve that going from here to here. I mean, why should I use this boundary condition for that? I have no clue. 10 people used it. Is that correct or not? 1/5 of the class. Okay, guys. So you understand what I'm saying then? Yes or no? So at X equal to 0, Y1 equal to 0, which is the black one, yes or no? Which many of you did correctly. So that means 0, 0, 0, C2 equal to 0. So C2. The funny part is this. The funny part is this. They put here X equal to 0. Then they said C4 equal to 0. Look, if I put X equal to 0, this is 0. Is this 0? This is -1. And this is +3. Is that 0 is -1, also -1. So you have to, how can the C4 become 0? Because there's something remembering that everything, because this one, everything is X. This one, everything is X -1. Even if you put X equal to 0, C4 is not become 0. Everybody understand what I'm saying that? But some people just close their eye, they just go ahead. But don't do that. It is there in front of you. Look at it, decide, and then you know you are making a mistake. Is that correct or not? Anyhow, at X equal to 0 applies to this line. This is the black line. This is the Y. This is the purple line. Yes or no? So this is equal to 0. Then what else do we have here? At X equal to 5, Y2 equal 5 meter, Y2 equal to 0, which apply to this one. Yes or no? Let's use that at last. But what is important here, this is the lecture was all about. How about that point? At that point, theta 1 equal to theta 2, y1 equal. And if you use this method, now this thing become a little bit simpler. So in between the two, this is the border line. At X equal to 1 meter, you should write theta 1 equal to theta. Now, if you expand it, you get into lots of math. If you don't expand it, look what happened here. Here you get 180 times 1 to the power of 2 over 2 plus C1 equal to 180 1 to the power of 2 over 2 minus what? Look what happened. If not expanded, minus plus C3. Look, this is the method I show you, but you did not follow it. Which then this and this drops out, then C1 become equal to C3. If you expand it, C1 is not equal to C3. Everybody understand again, right? I'm emphasizing this for you to know. With C1 and C3, I give you the number. You see, I have to do this much math extra to get to those. Everybody understand what I'm saying? It's impossible to do it any other way. And also write it down. So that is that one. So I'm going to erase that because I do not have. C2 already gone to 0 because we already established that one. With this one, is this equal to that? That's the case. Now again, the one, X equal to 1 meter, Y1 must be equal to 1, 2, because at these two, they are joining together. Only at that point, not at X. X means all of this. X means all of that. Everybody understand that? At X equal to 1, again, I have to write it. I don't have time. So as you see, this and this going to drops out. This one becomes C1 times 1. Is that correct or not? And the other one, because this, as you see here, this drops out. This is 0. This is 0. And then this is what you get. Here you get, let's put it there, 181 to the power of 3 over 6 plus C1 times 1 equal to 181 to the power of 3 divided by 6, 0, 0 plus C3 times 1 plus C4. Notice now this and this drops out. This is the way I did it in class 2. C1, because it's equal to C3, C1 and C3 going to drop. Then C4 become equal to 0. In this respect, only C4 become equal to 0, and that is the idea there. So this one is going. Now the only question is remaining, what is the value of C1 and C3. So some of you got it right. And that one, we have to use this one. Is that correct or not? Yes? So at x equal to 5, y2. Now, this is y2. So y2 becomes 0 equal to 185 to the power of 3 over 6 minus p, which was 16, times 4 to the power 3 over 6, minus w, which was 4, I believe, or 50, I'm sorry, minus 50 times 4 to the power of 4 divided by 24, plus C3 times 5 equal to 0. You solve it this way. As you see, become only one equation for one unknown, and that's why it become very simple. C3, which was equal to C1, become equal to minus 376.7, something like that, kilonewton meter. That's it. So that is the math. Any other method that you use, you expand that, you use from this side, you change your x's, all of that could work, but it's not a 15-minute job. Everybody understand what I'm saying? So you have to use that as I see. You get to the other one. Anyhow, some of you may have got the other one. If you expand it, C3 become equal to minus 430, C4 become 18.7. Of course, C1 will be the same C1. Everybody understand? But you solving 3 equations for 3 unknown for C1, C2, C3, it's impossible to solve. Correct? I keep asking you in class, do not expand. Yes or no? Correct? And if you expand it, you are that was the method. Anyhow, going back to the last part of a question, which probably I didn't give you too many points for that. And if you even didn't do it, I gave you credit for that one. As you see, some of you are surprised you get better grade than you expected. Yes or no? Correct? Therefore was calculating y at b. Now, what is y at b? Is this one or that one? Is that correct? Obviously, your y at b is common between the two. So why not use this one? Is that correct or not? Yes? So therefore, y at b become 1 over ei. Then all you have to put this equation, x equal to 1. Is that correct? So 180 to 1 to the power divided by 6. C1 is already given, times 1. You simplify that one, and ends up to be equal to minus 346.7 over EI. Now here is the unit problem that I'll have to mention it one more time. Again, the unit problem works like that. This, you put it the way it's given. You don't change anything. Don't change this into millimeter or kilonewton into newton. Let's do it the way it was given to us. Minus 346.7 divided by EI. What's the E equal to? E equal to 200 G Pascal. Yes or no? Which is 200 times 10 to the power of 9 Newton per meter square. Correct or not? Yes? Multiplied by I. What is the I is given? I equal to 900 times 10 to the power of minus 6 multiplied by 900 times 10 to the power of minus 6 meter to the power of 4. Yes or no? Correct? So what's the total unit? I gave you that in class. It equal to Newton meter square. Yes or no? Correct? Did we use here meter? Yes. Correct? So I don't have that. The only thing difference is this is Newton and this was kilonewton. So in order to match that, I have to multiply that to 10 to the power of 3. So kilonewton become Newton. Is that correct or not? Yes? However, the answer still is in what? Meter. And I don't want meter. I want the millimeter. So I should multiply. Notice what happened there. So what I'm saying that this has Newton meter to the power of the, kilonewton meter to the power of 3. This, as you see, has Newton meter to the power of 2. Yes or no? That's the unit. So this one, I have to multiply it by 10 to the power of 3. So kilonewton become Newton. Then meter 3 over meter 2. This drops out. I have 1 meter, but I don't want y in meter. Who wants to go meter? Y is in millimeter. So you multiply it by 10 to the power of 3 to convert meter in meter. So answer will become in millimeter. But as I said, we didn't go that far. I didn't go that far. You didn't go that far, but that's okay. Minus 1.93 millimeter. That's the answer. The same thing for theta. Theta, you calculate that based on radian. Is that correct or not? Yes? Okay, I went a little bit more detailed because I wanted you to see what is involved for future. So please, there are two facts that you cannot make a mistake. First of all, you have to recognize the difference between determinant and indeterminate, and then recognize between one. Now, to avoid this, as I said before, we went through you can now write this as a singularity system. Do it, solve it again. Everybody, but that requires only one moment equation from entire beam. Is that correct? Isn't that what your homework was all about? Correct or not? I'm hoping that all of you have done that and you know exactly what was involved there. So that was lots of questions to be answered here. And unfortunately, as usual, the average was not that good. It was still about 11, which is okay, but it should be much better. Now, going back to I have to do a couple of more superposition method. One thing that I forgot to mention, so I'm going to do one problem for you, so bear with me, is this problem. So let's do it this way so we can put number there, or you can, let's do this problem now. Here is a problem like that, which has a load here, like this, 30-inch, and a load here, 125 pounds, and this is 15 pounds per inch, and this is 10 inches. So point A, B, C could be one of your homework or could be similar to your homework. I don't know that, but I'm doing that. Is this one of your homework? Is similar to your homework? Is that is exact homework, this one? It changes, yes or no? But let's do it anyway. I'll put it on the board. Is that correct or not? Now, notice this system is not indeterminate. I just showed you previously what's the difference between determinate and indeterminate. Last week, Thursday, I did some determinate problem in superposition, one indeterminate. I'm going to do one more today. However, this is determinate. One fixed support, that's it. Is that correct or not? That's sufficient. So it's nothing indeterminate. However, depends what the question is asked. There are going to be these questions being asked. I don't know what are. Let's say calculate YC. These are the questions we want to answer, for example, or theta C, or YB. So I'm going to do one or two of them, not all, because it's time consuming. All of this could be a question raised in this problem because reaction is already there. This is determinate. I can find a reaction. Is that correct or not? Yes, that's not the question here. If it was indeterminate, that would have been a different story. Then you have to work out this system to get the reaction first. That's what you were doing, which I'm going to discuss it now. Okay. Now, how do we solve this problem? Obviously, I have to break this into two systems. Is that correct or not? So one system is simply a load here, 125 pounds, but the length is how many inches? The length is 40 inches. What I have not, or I actually overlooked last time, but I should have because that's part, you could have done more homework that way, is this beam, which is only loaded up to 30-inch, and the other 10 is free like that. Is that correct? Yes? Now I need to have again the table on the board. So that's why I have it here to show you what happened there. Okay, you have the table in your hand. We'll get it in a minute. We'll come on. So this change into two systems, yes or no? Is that correct or not? Is it on or not? So it takes a couple of, yeah, all right. Okay, it's coming on. Is that correct or not? So, yeah, we are on top. Is that correct or not? Let's see, we are calculating YC. How do you calculate YC? YC of this system equal to YC of system 1 plus YC of system 2. Okay, write it down. YC equal to YC of system 1, which is the top beam. I hope everybody can see from there, plus YC of system 2. Now, YC equal to, I put it all here. Is that correct? YC of system 1. System 1 is this one, yes or no? What's the YC? Is given. That's the one. Is that correct or not? Yes? The length is how much? The length is The length is 40 inch. Is that correct or not? Yes? And the load is 125, and exactly like that. And that is the deflection at that point. Is that what I want? I don't want the deflection at B. I need the deflection at C, and that's in the table. Yes or no? I do not have to use the curve. Is that correct or not? Therefore, that's equal to, look at there, that's equal to minus 125 times what? Times 40 to the power of 3. I'm just putting number there. Is that correct or not? Yes? Are you with me? Minus PL cubic divided by 3EI. Yes or no? Correct? Divided by 3EI. For time being, I put the EI there, and then at the end, we can add it if we want to. Is that correct? Sometimes we solve everything in terms of EI and put the EI. Now we come to, this is the reason I'm doing this problem. Now we come to what? Part 2. Now, this is the beam I have. This is 30 inches, and this is 10 inches. Yes or no? What do I have? And what? This is point B. This is point C. I suggest you always draw your beam. Don't do it in your head. That's what the cause of mistake. Then define your action here. What do you need here? Here, I needed this, and that was on the table. Yes or no? For this question. For this question, actually, I need YB, which is not in the table. Is that correct? Or is not here? Then I have to use the curve at x equal to 30 inch. Is that correct? Or L equal to 4. So I'm just discussing the whole. Now, what do I do for this part, which is only bending from here to here? Yes or no? What do I need? Do I need YB? Some people do that, by the way. This is the cardinal mistake again. They take YB and add it to this one. Is that correct? No. Look what happened here. I want you to understand that. This is a beam loaded like that. Everybody see what happened. The entire beam goes into curvature. Yes or no? Now, I have here load, uniform load or single load does not make any difference. Everybody should understand that. When I bend this, look what happened. From here to here goes through the curvature. Is the rest of it has a curvature or a straight line? Everybody see that? The rest of it is straight line, but it is tangent to this curve. Is that correct or not? So what happened here? You want to put this in your note. So this one become, this is in exaggeration, of course, become a line tangent to that. And you are not looking for this BB prime. You are looking for distance CC prime. Is that correct or not? Yes? How do we calculate that? That's the question. What is given in the table? L equal to how much, first of all? L equal to not 40 inch. L equal to 30 inch. So this is given. Let's write it down. This is this deflection, which is BB prime. BB prime is given. Is that correct or not? Everybody following what I'm saying? That BB prime is under the load. If load is finishes there, the rest of the beam doesn't matter. Is that correct or not? Yes? That is for the length of 30, not 40. So I'm putting here 30 inch again. So I get minus 30 inch times, minus W. W is how much? W was 15. Minus 15. Length 30 to the power of 4 divided by 48 EI. Yes or no? Is that correct? Or 8 EI? What's that? 8 EI. Okay, 8 EI. Is that what I want? No, that's part of it. Yes or no? That portion is equal to that portion. Yes or no? So that is, let's say, C1. C1 already given. I need that, but this is a geometry. Everybody understands. And this is the routine that you have to learn. This angle is what? One more time. That angle is theta at B. Yes or no? Yes? So if I give you this is theta at B, and I give you this is 10 inch, can you calculate that one geometrically? Yes or no? It's a triangle with the angle is given, the length is given. Is that correct or not? Yes? So I put it here in general. This is what's going to happen. If this happened to be a straight line, please write it down. And this is theta, and you are looking for distance, then D depends on this distance A, everybody. The more down you go, the further it goes down. So you write it like that. Tangent of theta equal to theta. Why? Why can I write tangent theta equal to theta? Because theta is very small. It's less than 1 degree. Everybody understand? Otherwise, if it's 30 degrees, I cannot do that. Everybody understand that. Since theta is very small, tangent theta equal to theta equal to d over a. Is that correct or not? I'm not looking for a. A is given. Theta is looking. We are looking for d. Therefore, d become equal to a times theta. This formula, you don't have to remember it. It's all going to happen many times in your homework. When you want to extend the beam further of the load, you have to use a triangle rule. Is that correct or not? Yes? So therefore, what do I need at that point? What this is C1. This C1 is that D. Is that correct or not? What is the A value is 10 inch. But I need the theta at that point. Where is theta at that point? Look at the theta is how much? You see, that's the slope. Is that correct or not? The slope at that point is minus WL3 divided by 6 EI. So you write the slope there, minus W30 to the power of 3 divided by 6 EI, which is the theta. You need to multiply it by this. You need to multiply it by 10. Is that correct or not? To get the distance. So multiplied by 10, the unit works, etc. And this is A. So that's what I put there. Theta and A. You have to use this technique anytime you go beyond the load. Everybody understand it? Correct? Look, another homework problem. You see, you are all quiet. You see that if you are looking for YC, when you break this one, you have this load at C. But when you do this one, the load is here. You want this goes like that, then goes a straight line. Is that correct? It's as simple as that. Is that understood by everybody? So I don't want you to do any mistake that you go beyond the load. After the load, if this beam is going to expand it, it's going to there is going to be a triangle rule. Is that correct or not? Which consists of, one more time, this and this theta and this length. That's all you need. This, which is already, I put it there. See that? This is case 1. For case 2, I have this combination. First, I calculate BB1. Then I want CC prime. Yes or no? But CC prime equal to theta times 10. Or tangent theta times 10. Is that correct or not? Yes? Everybody's so quiet. Yes or no? Yes. What's the difficulty? Did you get it? Big Brother's watching. There are Big Brother watching. Did you get it? It's so easy. So easy. Yeah, that's what I'm saying. If it is so easy.
The last part you said what equals 10?
What?
You said 10 theta equals 10?
I put it there.
Oh.
If, God, this is high school. If this is theta, and I give you A, I want D, how do you calculate the D? Tangent theta equal to D over A, yes or no? But tangent theta equal to theta, because this is small, it's 1 degree, it's less. Is that correct? Tangent theta, D become equal to A times tangent theta. Yes or no? D equal to A times tangent. But instead of tangent theta, I'm using theta, because if it is less than degree, they are the same. Is that correct or not? So what do I need? I need theta at that point, because this is the slope of the beam at that point. Yes or no? That's the theta, and that's the 10 inch to get that to little geometry. But you are all looking as if I did some magic. I didn't. It is just simple fact. Correct or not? Yes?
And theta, you said it's radians? Does that make a difference?
Yes, of course, it's radian, not in degree. Of course. Come on, if you don't remember that I did that in ME, in a static class, or ME, don't remember that. Take a tangent of 2 degrees, change it in radian, do it, because I don't have time to take your calculator, everybody. I think I did that in ME 218. I don't have to do it here, but just since you asked, take 2 degree, change the 2 degree to radian. What do you get? Theta equal to 2 degree, change it into radian. Theta become 0.0 something. Is that correct or not? What do you get? 0.0349, okay? Now get sine of theta. Look what you get. I just the answer here. You just check me. Is that correct or not? Okay, and get the tangent of theta. I write the answer, 0.0349. Is that correct or not? Yes? Why? Why? Sine and tangent and theta in radian, they are all the same. Why? Because the angle is very small. So I can use it. Yes? You want to use tangent theta, use it. Is that correct? Theta does it for me. Yes or no? Correct? Because this is small theta. We did that in ME 218 to show you. Actually, if the formation is not small, I cannot repeat this for this class and then move on with the lecture. It is such an important thing to know. Actually, everything that you learn in ME 218 works if the formation are small. If the formation is big, none of this will work. So you cannot apply that to a plastic deformation. It doesn't. It has to be an elastic material. We are talking about still because all the deformation and all this slope. Anytime you walked into this beam in this room of upper people, do you see that this beam is bending like that? It's not a cable that bends like that. It's that the cable does not follow this rule. This is all about very minute y, many minute theta. Everybody understand that. So this rule applied. Everybody see that? For angle less than 2 degrees, if you go to 3 and 4, still you can use it to 3-digit accuracy. But after that, you lose the accuracy. For larger number, this is not true. Is that correct or not? For a small angle less than 2, theta and sine and tangent, they are all the same. That's what I'm using in different formula. Is that understood? Yes? Correct? So I'm using theta instead of tangent theta times 10. So it's nothing there. Anyhow, this is the end of a story. You can use that in your system. Is that correct or not? Let's do another problem. So I'm going to erase that. That technique that I put it there, you should put it in a box and then follow it into different system because this happened a lot in your system. Yes?
So for theta at c, it would just be theta 1 plus theta.
Okay. Theta at c. That's a very good question. Let's because I just wanted because we discussed that. Now let's calculate theta c. It's a very good question. Now if you understood what I did here, theta c, for this one, I have to repair to the table. Yes or no? That's what you are asking. Good question. So for that one, this is the theta c. Yes or no? Minus p, let's do that. So for that one, this was yc. The yc consists of system 1, but system 2 is this, which I added one more time, this to that. Is that correct or not? Geometrically, I did it, which is end up like that. Now I'm going to erase that, and this time because I asked you to calculate theta c, that's why he's asking. So theta c become equal to the theta c, this is theta there. Is that correct? And it's given in the table. How much is it? Minus p L squared divided by 2EI. Very good. Minus p is 125, times L squared, you said? Yes, L, which is 40, that's right, squared divided by 2EI. Correct or not? Now coming to theta c. That was his question. What's theta c equal to? Theta c is equal to theta b because this is a straight line. Yes or no? The straight line has the same theta. Yes, correct or not? So I don't have to adjust it. Is that correct or not? Is that what you are asking? Yes?
So do we add the two?
So this theta is equal to that theta. Yes or no? So theta at c is equal to theta at b. So theta at b, how much was it? Was minus w. How much was it? Minus w. L3 divided by 6. So I don't have to add anything to it. That's what I thought that was your question. Is that correct or not?
Which L do we use for the second one?
What L do you think I should use for the second one? What's the length of the beam? Where's the length of the beam? The length of the beam, according to here, is the length of the load. The load is how much? 30. Yes? I'm going to do it. We already did it before. So I don't know why you are. This is minus 50, or what? 15. I'm sorry. 15, 30 to the power of 3 divided by 6 EI. And that's the answer. That's the theta. This is a little bit of adjustment that you have to do according to your table. Everybody understand that. So this is, of course, with the same rule that I said, look, one more time, guys. Look, if I do this, as you go further, the deflection become more. So it depends on the theta and depends on the length here, the 10-inch length. The 10-inch become 15-inch, delta become, y become larger. But since this is a line, no more curvature, theta stays the same from beginning to the end. Yes or no? So I can use it here, I can use it there, because that's the same line. Line have the same angle. Yes?
So for an exam, would you give us this table, or would you?
Of course I will give it to you. You don't have to remember any of it. You want to remember? No, that will be another course for 4 units to remember all of that. Are you kidding? Of course not. I will give all the table to you. But how to use the table is the question. You have to practice it through example. I think this is very simple. I cannot spend any more time on this one. I don't know why you are sort of quiet. This is just a geometry. Tangent of theta equal to d over a. Calculate the d. Is that correct or not? Yes? So that is so simple, maybe you are surprised. I don't know, whatever. Is that correct? Let's do another example, which I did it for the other class as well. So let's put that down a little bit. So this time, this is the practice of this. Now, be careful of what you are saying and what you are doing. In this table, I already talked to you last time about all the significant part of this table. The rest is you. The only problem that people have with this superposition method, they do not define their action first. So be careful what you do. Every time you want to use superposition method, you have to see what you are doing or what the question is being asked. Look at the next question. Now this time I'm going to practice this part of a table. So here, maybe I went a little bit too far down. So let's go a little bit higher. Okay, that's the one I want. Okay, this is the problem, guys. Write it down. It's not in your book. So this is, or in handout. If I put here a 400 Newton load here, and 400 Newton load there, and this is 1 meter, and this is 1 meter, and at the middle 2 meter, this is no problem for you to calculate the reaction, because this is a determinate problem. Actually, it's symmetrical, so each reaction becomes 400 and 400. Is that correct? So that will not be a question to ask. Is that correct? However, if this is the system, I can ask you to calculate theta at A, or what else did I use for this problem? Let's use the same format that I used it before. So here we go. If I can find it. Oh, here it is, finally find it. So here I use A, here I use C, and now I'm going to change this problem by putting one more support here. This is 1 meter, and that is 1 meter. So the length of the beam is 4 meter, and then at the middle of the beam, there is an extra support. Aside from A and C, there is another support at B. Everybody see what I'm talking about. Is this a determinate problem, or is this in there? I don't want you to get wrong, because when I gave you homework last time, 3 problems you have indeterminate problem, the rest was determinate. To the other class, I give a quiz which was indeterminate, and few people missed it. For you, I gave you a quiz which was determinate. Some of the students in that class objected to that. I said, why did you give them the easy one and we had the difficult one? Because some of them totally missed the indeterminate versus the determinate. Everybody understand? This system right now is indeterminate. Why? Because I just did what I did. I added a third support there, yes or no? Now you have 3 vertical load and 2 equations of equilibrium, sigma Fy equal to 0 and sigma m equal to 0, which you could never find a reaction unless you do some crazy things that happen in the other class. Is that correct or not? Yes? That means that indeterminate problem is not, static equation is not sufficient to solve those equations. Yes or no? Correct? Everybody with me? Now, how do I show? I want to use superposition method to find the reaction at A, B, and C. Do exactly what? Is this a support there? Yes or no? If I take this support out, what should I put underneath it? I should put there a reaction. But do I know the magnitude of that one? No. So I'm going to put it there. Look exactly what you just feeling about it, and RB there. Yes. If somebody comes and suddenly tells you RB equal to 100 Newton, is the problem solved? If I give you, look, you have to look at the static of the problem. This is 400, this is 400. If this is 100, doesn't need a genius to find out what A and C is. Is that correct or not? If I say this is 100, this is remaining 700, which is symmetrical. So 350 goes there, 350 goes there. Yes? So suddenly the system from the indeterminate become a determinate. The question is, what is RB? Yes or no? So that is your criteria. The question is, if I calculate RB, then I don't have to worry about A and C because then I can use equilibrium to solve for the other one. That's what I'm saying. That yes, RB equal to what? Is that the question? Yes? However, anytime you have a reaction, you have a boundary condition. What's the value of y at that point?
0.
So why not use that as your criteria? Is that correct? You have to set up, if you break this into 3 different beams in different load, when I add those 3 beams together, y at b must be equal to 0 because this is 0. Look at it. This beam is going to bend like this, something like that. Is that correct or not? Yes or no? This means y at that point, that's exactly what it means. Y at that point must be equal to 0, correct? Now let's do that. So in order to do that, we are going to break that into 3 systems. Let's go a little bit quicker. So this is 1. I put a 400 load here, Newton. This is 1 meter. This is 3 meter. I have to go according to the table. I show you the table. Is that correct or not? Yes? And then we have to go to this beam, which has a load at the middle, RB. Granted, RB is not known. Is that correct or not? Yes? However, this beam is going to bend like that. Is that correct or not? This beam most likely going to go like that and go like that. Is that correct or not? Because this is heavier this side than the other side. Correct or not? Yes? And finally, we have another beam. You don't need to draw this. This dashed line just to tell you what the idea is. And this one, there is a 400 here, which will be a mirror image of the other one because it's symmetrical. Sometimes some of your homework is done. So this goes down there, this goes like that. Is that correct or not? Yes? Is this going down? Now, here is the key. This is A, B, C, D, E. Where is D? This is point D. This is point A. Look at the table. At the table, I have this. Is that correct or not? Yes? And look at this. This Y max or whatever given. Is that at the middle or is it where I want to? No, it's not. Is that correct or not? This is at certain different point. This is Y max happen to be at here. You see here it says this is X max. Is that correct or not? Yes? Therefore, what do I want to do? I want you to look at the curve. Is that the curve? Is that correct or not? Look what we need. We need not at D, not at E. We need deformation at point B. Yes or no? Isn't that what we want to set up? What is this B? This is YB. Is that correct or not? So YB of this beam plus Y of this beam and Y of this beam, is that correct or not? Together should be all together must be equal to 0. Correct or not? Yes? That's the question you want to answer. Now, you draw this or at least show me there. Then in the math part, you make a couple of mistakes here. That's not a big deal. But not putting this and not defining your system, doesn't get you anywhere. Is that correct or not? Again, one more time. Since this YB pushes beam up such a way at this point you have no deformation, when you break it into 1, 2, 3 system, the sum of the Y at the same point B must be equal to 0. You cannot add, this is what the mistake a student makes sometimes. They add this maximum to that maximum to that maximum. That's irrelevant. Everybody see that that's a wrong approach. Yes? Okay, so we want this. We want this, call this system 1, system 2, and system 3. We want YB of system 1 plus YB of system 2 plus YB of system 3 together must be equal to 0. Now let's see whether we can read it correctly. You have your table in front of you. Hopefully, if you want, take a look at that. The one that it is easier. Look at this one. First of all, look at the table. What the table there? I mentioned that last time. I don't know whether you recognize it. I mentioned it in class. A must be larger than B, and I said if that's not the case, you have reversed it. Is that correct or not? Which one is true? Which one matches this one? Not the first one, not the second one, the third one. Yes or no? Look at this one. This is A. Yes or no? A equal to what? 3 meters. Yes or no? B equal to 1 meter. What is X? What is the distance X? X equal to where am I? At the middle of the beam. Yes or no? X equal to what? 2 meters. Correct? I need Y at the middle. Yes or no? Correct? So which one can I use this one? Of course I cannot use that. But I cannot do. What do I need? I need for X less than A. Is that correct or not? I use this equation. That's the value of B. That's the value of P. That's the value of A. L equal to what? L equal to 4. X equal to what? X equal to 2. Everybody. B equal to 1. A equal to 3. Is that correct or not? As the picture shows. That's exact. So that's exactly what I'm going to do that. So the first one or the third one, I'm putting it here. YB of 3. So let's do this one first. So that's what I'm saying. So P is equal to RB. No, it's 400. I'm sorry. 400 times what? I'm not looking there because I need another table from you. Anybody has a table? No. Yeah, okay. Thank you. So, okay, 400, times B. B is 1 divided by what? Divided by 6 EIL. So 6 EIL, L equal to 4. Is that correct or not? Yes. Multiplied by X to the power of 3, 2 to the power of 3, minus L to the power of 2, which is 4 to the power of 2, minus B squared, 1 to the power of 2, and the whole thing multiplied by 2, and this is a bracket. Notice, people think this is positive, but it is not positive. This is a negative. I mentioned that because this quantity become 3 as it's larger than that one. Everybody understand? This quantity is larger than that one, so the whole thing is negative. So don't worry about it. That is this one. Is that correct or not? To that one, I have to add this one. Yes? Is this in the table? Look at it.
Yes.
That is at the middle. This is not this one. This is the other one. Yes or no? This is good. What do I need? I need Y max. Yes or no? Y max equal to how much? PL3 divided by 48 EI. However, P is going down. My force is going up, so I have to change sign. It's obvious. Is that correct? So it comes plus RB, because now I don't know the RB. That's the RB become my load. Is that correct or not? Yes? Multiplied by, I'm here. You said that, L3, L is how much? L is 4 to the power of 3 divided by 40 EI. Now, what do? Now, I did this one. I did actually backward. I should put it on the button because this is the way. I did that one. I did that one. Now we get to that one. What should I do that? What? I said, no, this is 2 things. First of all, I have to reverse it, yes? So I reverse it. I go this way. Is that correct or not? So A become 3, B become 1. So I have to look at that. However, since this is at the middle, doesn't make any difference. Is that correct or not? Yes? Because this is equal to that. If it was here, then it would have been different story. I have to add 2 different numbers together. Since at the middle is the same, so all you have to do, multiply that by 2 in this problem. Now, notice if there was any other location, you have to change that. Is that correct or not? Yes? So therefore, you multiply that 2, that become equal to 0, as you see in this, because the static has nothing to do with the EI. EI is going to drop out. Static never is dependent on the EI. EI will be drop out there. So use this one equation, one RB. You calculate RB. RB become equal to 550 Newton. As soon as you find RB equal to 500, now this become a determinate problem. Look what happened. RB equal to 550 Newton. Correct or not? So all this superposition, and practically every method, all the method I give you, double integration, for direct method, all of them, when it comes to the indeterminate problem, actually solve the static for you. Is that correct or not? After static is done, then you can draw your shear and moment diagram, then you can design the beam, and that's the end of the story. We always check the deformation, but deformation is for some machine part, something you want to have very small deformation, and we always be careful about that. But deformation is not the issue generally. First, the design is the issue. Is that correct or not? But after you design it, you don't want deformation go beyond certain limit as well, because after all, your equation is not going to be valid anyway if you have large deformation. Is that correct or not? However, that becomes issue. As you see, all this method finally gives you your static. So this now static is the RA and RB. Of course, is symmetrical. So this one become 250 length divided by 2. So this becomes 125 Newton, and this is 125 Newton. Then the problem is done. Another type of problem, which is very important, is let's keep that one table here, is your handout. Look at the handout. On your handout, there are 3 problems there. And one of your homework is similar to that one. You have to understand, again, the concept of the superposition. So what we are doing that. There are 3 handout problems. Number 1 and 3, you are supposed to do it. Number 3 actually is very simple. You have to be careful how many unknown you have and how many equations you need. Number 1 is the one is your homework. I'm going to do number 2. Number 2 is the following problem, right? Which is a beam coming here, a fixed beam. This I can show it 3-dimensionally or 2-dimensionally like that, sitting on another beam here. And this one has a roller support here and a pin support there. This is a fixed support. This is 1.5 meter. This is 1.5 meter. This is 1.5 meter. This is not in the scale. And there is a uniform load of, I forgot how much was it, a uniform load of 4 kilonewton. A uniform load of 4 kilonewton per meter is on top of that, and we want to solve this problem to calculate the reaction at the support. Obviously, this is a special problem. This does not qualify for any other method. Actually, superposition method is a good method for this type of problem, yes or no? Which happens a lot in all the engineering work. You are designing a beam sitting in another beam. Everybody understands that. Crossing each other, what's going to happen between the two? Is this, first of all, determinate or indeterminate? Indeterminate. Lots of reaction. Is that correct or not? Now, what is the key is important as far as you guys as an engineer. Notice, I have to mention a few things here, which is important. You have seen this problem. Actually, the first problem that I did as indeterminate problem is this problem. Remember that? Is that the same problem? Yes or no?
Yeah.
Half. Okay, you modified that. Yes or no? That's the answer. Yes and no. Which one? No. Yes. Yes, because it looks the same. Yes. You know what the difference between this and that? If this is point A, and this is point B, and this is point A, and this is point B, is this point B going down? Not. No, that's the whole thing. This is a rigid, this is sitting, this is a beam, elastic beam, sitting of massive concrete, which is rigid. It's not moving at all. Is that correct or not? Then, here, is this happening the same thing or not? If this is plastic and this is a rigid beam, yes, but is this beam going to bend? So that point B is not going down. So that respect is not the same. It looks the same, but it's not the same. I want you to understand the difference between when we put a support there and when something is moving up and down a little bit. Is that point B goes down or not? Yes. Okay. How much down does it go? Depend on the flexibility of the lower beam, if I put something like a plastic like this, which does not take much load to bend, it has no effect. If I put a concrete bit on top of that, it's going to crush this. Is that correct or not? Everybody understand that? However, if I make this of a steel beam very heavy, it's going to resist the other one. How much, we don't know. Is there going to be a transaction or force transaction between the two beams? Yes or no? Do you know the magnitude of that? No. Therefore, this is the scenario. This is something you have to figure it out. That's why I gave you a couple of this homework. Now, you are, I call you junior engineer. Did I call you junior engineer before or not? You are a junior engineer. You have to think like that. You have to resolve this issue. You are going to design part of a thing that is not in your textbook, something similar to that, which happen a lot. Is that correct or not? However, analysis of that is this, that you have here a lower beam. Let's draw the lower beam first. Is this the lower beam? And this causes, let's put it in color, because when it is in color, I put it as a dot. Is there an R here? Yes or no? Let's put that R, that's a load. Is that top beam pushes the lower beam down? Yes or no? Is the lower beam is going down like that? Is that correct or not? Yes. This is point C. This is point D. This is point B. Correct? Yes. What happened to the upper beam? Can you draw me the free body diagram of upper beam? This is case 1 or free body diagram of this beam. Is that correct? Or beam 2? Let's put it. This is beam 2. I put here beam 2. Is that correct or not? Yes? Maybe you want to call this then case 2 as well. So that's that, right? Now, case 1 is this. Is this the case 1? Yes? Is that complete or not complete? Not complete. What do we have at this end then? A force going equal and opposite. Is that correct? This is the representation of free body diagram of upper beam, free body diagram of the lower beam. The only thing is, what's the value of R? We don't know. Yes? The question is, what is R? Now, if I want to calculate value of the R, which is push it down here and that one, what should I say? Now, the condition is set there. What is the condition now? Y at B. This cannot go down here and that stay up there. The two of them going together. Is that correct or not? So you have to write, this is system 2, this is system 1. Is that correct or not? This is the key. You draw it like that, then you say YB of system 1, which is this one, must be equal to YB of system 2 in the same magnet. In other words, if this one goes down quarter of an inch, this one must be going down quarter of it. Yes, everybody agree on that? Yes? However, this one is very simple to calculate. This is system 2. How much is that? Is this in the, look at this beam. The load is right at the middle, yes or no? We already use it. Which one is that one? That one is that one, case 4. Yes or no? How much load, how much deflection do I have at the middle? We already use it in the other problem. Minus PL3 over 48 EI, but the P changes to R. Okay, so this one, the right-hand side, this one. I put it here now. The right-hand side is R, minus R is going down. Minus R, this is the L is how much? L equal to, look at the L. L equal to 3, yes or no? No, but they are not responding. 3 to the power of 3 or 4? 3 divided by how many EI? 6 EI? 48. Fine. Is that the deformation of this beam at the middle? Yes or no? Which is symmetrical? Yes? Which is case 4, symmetrical. This is unsymmetrical. That's the only reason I'm doing all this problem. Yes or no? Correct? So therefore, that is the deformation I want. PL3 over 48. Correct? Now we come to this one. Now, is this one load or two load? Two. So I have to break it into 2 parts. Is that correct or not? Then this becomes equal to, now you're getting the idea. You get this one, which is causing this to go down. Yes or no? Plus what? This one, which causing to go up. But this total of this one must be equal to that one. Yes or no? correct? This is case 1A. Let's call it 1A. This is case 1B. Is that correct? But two of them together will be this one. Yes or no? Correct? Now, how much this will go down? This is which case is that? Do we have it there? I have to pull it down a little bit. So let's go, or up, sorry. Is that one? Yes or no? Correct? That one. Everybody see that? This one? Oh, you don't see that. Okay. This one, yes? And how much W do we have? This much, yes or no? Minus W, L4 divided by 8 EI. So minus W is going down. Okay, minus W. W was how much? 4 kilonewton. Let me look here, so I have it here. L4, what's L for this one? L for this one is 1.5, so you have to be careful here. 1.5 to the power of 4 divided by 8 EI, correct? 8 EI. Yes, 8 EI. Is that correct or not? Now I have to add, this is negative, this is positive because it's going upward, yes or no? But this one also is in the table. I have to go a little bit further up. Is that one, yes or no? Is this that one, yes or no? Yes, but in opposite. This is negative, I need to put it plus. So plus R times length. Length is, again, 1.5 to the power of 3 divided by 6 EI. Is that 3 EI? Okay, good. 3 EI. Yes, so these two must be, again, equal. Now, there are sometimes the problem is like that. The EI of this beam and EI this beam could be different. This could be aluminum, this could be steel, or vice versa. They have different size, but that you put it here, but they eliminate, or one become twice as much the other one, or one become half of that. But nevertheless, in this case, I'm assuming EIs are the same. So I assume EI same for both beam. Write it down. For both beam. It says in the problem. It's in your handout. So if that's the case, EI and EI will drop out. If not, you plug in the number, there will be a ratio. Is that correct? Let's say if this is 30,000 KSI, this is 10,000 KSI. Okay, so you put it there, so ratio 3. Nevertheless, this is a formula for R. Is that correct or not? You solve for R, R become equal to 1.5 kilonewton. So that solved the problem for you. As soon as you find the R equal to 1.5 kilonewton, all the static is solved, because this become 1.5 kilonewton, then this reaction become 0.75. That is, you can find it there. This is just simple static enough. Now, for the other class, I had about 10 minutes to give them the preview of next chapter. Now, I want you to understand what all next chapter is about. Just give me a couple of minutes, and I'll let you go. I don't have that one. We are done with all the superposition with it. All the beam. We are still about one class behind or half a class behind. We can catch up. However, next chapter is very important for you guys, especially for mechanical engineering. Now, I need you to know this. In order to understand the next chapter, which I'm going to go quickly over, and there are lots of fancy problems coming at the end of it, which is the real life scenario problem, is this. You need to know the strain, shear strain, which is what? Gamma. You need to know the normal strain, which is epsilon. Not in one-dimensional, in three-dimensional. Epsilon equal to sigma x over E minus nu sigma y, Poisson ratio, shear strain, normal strain, everything that you learn in chapter 1, everybody in ME 218, plus the fact you need to know the Mohr circle, plus the fact you have to know out of plane, in a plane, everything we talk about the Mohr circle, which you are now presumably good at it, hopefully. And then we have to now do everything that we need for strain. Now we are measuring the strain, because when we test a model, we measure the strain. We never measure the stress. Everybody understand that. You are sitting, as I said it for the other class, you are sitting in the airplane. In the airplane, in every part of a wing or the body, there are strain gauges all over the place. So strain gauges measure the strain, not the stress. The stress is in the body. You can never go inside the body. But you can measure the strain. When we get the measured strain, we can now go back check to see what kind of stress is called that kind of strain. So we need to draw the Mohr circle for a strain. We have to understand what the plane stress is, what the plane strain is, what the absolute maximum strain is, and all of that. All repeat in a way, very simple repeat, with one exception. You have to understand the concept of a strain, which is in chapter 1. Is that correct or not? I'm hoping that you get a chance to take a look at it. I asked you to do it over the weekend, but I have no choice but to go ahead, assuming you know all about that, which is in chapter 1. Take a quick look at normal strain, shear strain, Poisson ratio, and the relationship, at least to get that idea.